Welcome to the CFD course, CFD Modeling of Turbulent Aerodynamic Flows. In this course, you will learn how to solve the turbulent flows using the 4 softwares. Here you can see that the geometry of pipe is created in Design Modeler. And here the geometry of the aerofoil is created in the Design Modeler using the input files in terms of the text files. And there are the different formats for the depending on the trailing edge of the aerofoil. So for the closed type and for the sharp trailing edge and the square trailing edge, we have the different format. The only difference is in the last point. When we have the sharp trailing edge, the last point will have the 0 as the serial number, and in the coordinates you have to keep it blank. But in the case when we have the square trailing edge, the last point should have the same value as the last point of the lower side. So only difference is that here we have the minus in the y direction minus 0.00126, and here we have the first point is the plus 0.00126. Not only we will teach you on the software directly, but also I have created the slides so that you can have the black and white, so you can refer them when you want to. So here you can see that there are 2 types of the aerofoils, and here is much clear to explain on the slide than on the software, that we have the sharp trailing edge and we have the open trailing edge or the square trailing edge. And the data of the aerofoils we get is from this website, and then we arrange them in the Excel in this format, and then on the top side we write down some text. And last point is a Z point, which is not in the 2D aerofoils, but we have to include because the file formats requires the data to be the 3-dimensional. So that's why we are putting the 0 value here. And here we have the extra details about the geometry. So groups of 1. And the points, they will be in the order of how the number of points are increasing. So 1, 2, 3, 4, 5 up to 81. And here the format for the closed type. And here the files are copied. These coordinates are copied in the text file in the Notepad++. And then all the procedure is explained in the Design Modeler. The same geometry is taken from the same website, or maybe slightly different website. And they are arranged in a way which is acceptable to the ICM CFD. So this is the file format for the ICM CFD. So we are teaching you that how you can make the geometry in the Design Modeler, which is mini-CAD software for the ANSYS Workbench. Also, you will learn that how you can create the geometry in the ICM CFD. So here is the overall procedure given. How to import them, then create parts, and then everything mesh, and how to the first cell height, the quality, and how to create the 3 meshes, coarse, medium, and fine, to make the mesh independent study. And then here we have solved the same case in the Fluent. So starting from the problem description, then geometry, then meshing, and then finally solution, and then we compare results with the external data. So if there is some error, we go back to the geometry or the meshing step and correct them according to the requirements of the problem. So in this course, you are not only to solve them, use the software, but you'll understand the problem, and accordingly you have to set the settings for the problem. And here all the details are given in terms of the PowerPoint slides. So starting from the first step of the meshing import, and then solving, getting data of the drag, lift, pressure coefficient, and monitoring the solution convergence, velocity contours, velocity vectors, pressure coefficient. And also in this course we have compared the data with the external data and also with the data available from the NASA website. So this is a high quality CFD results from the NASA website. So we have compared our data, and if we find some problem, then we go back again to the meshing step. But because we have adopted the well-established best practices, that's why there is a least chance that we should be going back to the other steps like geometry and meshing. So in the first step, you will be able to get the very high quality results. So you can see here that here we have the CP plot from CFD and here CP plot from the NASA website. And then I use this software web plot digitizer, this data into the Excel format, and then this is compared in the Excel format. And you can see here that here data is upside down. So here in the Excel, this data is also changed so that the -6 should be on the upper side and the +2 should be on the lower side, so that we can compare the data with the NASA's data. So this all techniques, all tips and tricks are discussed and explained in a very detail in this course. So please just join this course and brush up your skills in the CFD, especially in the turbulence modeling applied to the CFD problems. Thank you.